Okay, so the first one I kind of asked you to do something much harder than I originally supposed, but we should at least be able to factor this. It has all complex zeros, so we'd have to do like synthetic division with i's, which you can do, it's just kind of a mess. We're not going to do that, okay? Not in this class, we don't really need to. So first you need to think about it like this. Are we all clear that this is the same as that? Yeah? The reason we're thinking about it like this is because now we've got cubes that are summed, and we have a formula to factor the sum of cubes or the difference of cubes. Can you factor the sum of squares?
No.
Let's remind ourselves, like you can do difference of squares. Can you factor this though? Is that equal to like x plus 2, or like, I should go 4, like x plus 2 and x plus 2 or something? It's not. If you set that to 0, what kind of answers do you get? If you don't see it, do it. You get imaginary answers. If you have the sum of squares, you always get imaginary answers. If you have the difference of squares, you can factor it. But for cubes, they factor either way. Either one factors, so that's nice. So from the formula for yesterday, let's see. You guys are going to have to help me remember. You know how bad I am. So how's this going to go? With our problem, though. 2 plus z squared, because that's what's being cubed there, isn't it? And then over here we put like 2 squared, and over here, I always go the outside ones first. Z squared squared is z to the 4th. Does that make sense? And then in the middle, we have, okay, so this one's plus, so it goes plus, minus, plus. So in the middle, we're going to have, I think, 2, one of those and one of those, 2z squared. Sweet. There we go. Factored. Maybe this part might factor further. We could try. You guys want to try? Let's see. So that'd be like, let's turn it around. Z to the 4th minus 2z squared plus 4. Does that factor? Think of it, see how it goes just like a quadratic? It's just like squared x, like x squared x number. So it would factor just like a quadratic. But does that work? I think this is the one we did yesterday, isn't it? Factors of 4, 4 and 1, 2 and 2. So I think that we'd be stuck at that point. And that makes sense because when we looked at the graph, they were all imaginary. So we'd have to do lots of synthetic division. What would be some things we'd have to put into synthetic division if we were going to try to actually get the I answers? I mean, you certainly can. It's just a pain. This is a hard problem. So a couple of the I answers I think we can get real quick right now. From this part or from this part. Isn't the first part simple? We could have done that way back in chapter 5 or whatever it was. Set it to 0. 2 plus z squared equals 0 minus 2. So z is plus or minus root 2i. So if we really wanted to find, how many more are there? There's 4 more, right? And they'll come in pairs, just like this. We could start by doing synthetic division with root 2i. And we could do that with like 1, 0, 0, 0, 0, 0, 0, 0, 8. And then we could go from there. And it would be a pain because doing synthetic division with i's is
Not fun.
It's not too much fun. It's kind of fun. I don't know. It gets messy though. You can make the mistakes easy. But we're just going to say we're done, okay? So we're done. So if you guys get a problem like this, you can just go for it right here and say, you know what, that's factored as much as I can do. All right? So this one we can definitely do though, I think. It's got one little new thing.
It's got 2 of them.
It's got what?
2 zeros. One at 0 and one at 2.
So it looks like what?
It comes up from...
Which side does it come up from? Can somebody tell me?
The third quadrant.
It comes up from over here? Did it?
Yeah.
And then what's it do? It goes through where?
It goes 0, 0.
So something like this? Okay. We're thinking snake shape, right? Positive snake shape, and then it goes... Does it go through or bounce? It bounces. That's something new. We need to think about that. Then what's it do? It doesn't go down forever? It like stops somewhere and it comes back up through... Okay. So something like this? That makes sense with an odd degree snaky function, right? I think that makes sense. So there's no reason to suggest it would like come back down. It's odd. Okay, so now what do I do?
I guess since you have
Synthetic division.
yeah, 2.
We know 2 is going to give us a remainder of 0. So let's do that. So I might need some more space. I'm going to erase this one. Let's go over here. So we'll go for 2. We're going 2, 0, 0, 0, 0. My goodness. You can do this fast, right? I mean, so we go 2, 4, 4, 8, 8. Don't go too fast, though. Don't make a mistake. Synthetic division is pretty fast, right?
Yeah.
As long as you're a little careful.
Then it's next to go.
We knew that was going to happen because we saw it on the graph. So then we say another good thing to use synthetic division on is
0.
0, because it also showed up as a 0 on the graph. So we say we'll use it, see what happens. Try to keep my colors straight. So we go 2, 0, 4, 0, 8, 0, 0. Oh my gosh, this is just weird. Oops. Like that. Did I make a mistake? Check me. What's up? We are trying to get all your zeros, and how many do we have?
No.
Well, we have 2 so far, but how many do we know we're eventually going to need?
5.
5, because that's the degree. I mean, some of them might be imaginary. In fact, we're thinking some of them have to be imaginary, right? There's a couple things to think about at this point. How many left do we have to find then? We have 3 left to find. Didn't we learn something about imaginary numbers? Do they ever come by themselves, pretty much? They always come in. But we have how many left? 3, so there has to be a real number left that we're not seeing. So maybe we need to stretch our window out. That might be one good idea. So some of us have been good. Tried that and you just couldn't find it. I mean, what if it's like really huge though, Rachel? Think about this. Does this have any really huge numbers in it? So I doubt that there's going to be any really funky, strange zeros. I'm just putting that in there. If there's like a 0 out of a million or something, what do you think is going to happen in here? There's going to be like 1,000 coefficients and stuff like that. You know what I'm saying? We're not going to run into anything like that. Could happen. But. So I think the other real 0 is hiding out. I see it. Anybody have a guess as to what it is or how we can think about this?
Maybe. Is it 2?
So we tried this one.
2 something.
We tried that one. There's another one.
That one.
Courtney?
Is it the minimum?
Ah, good guess. That's a good idea, but that's not a 0. I mean, a definition of a 0 is an x-intercept. It has to be an x-intercept.
Well, wouldn't it be where? Well, 0 again.
Do these do the same thing? Is the behavior the same at each one of these guys?
Uh-huh.
What's this one do? The function goes through it. What happens here? It like bounces off, I like to say that, or it touches the axis. So that's 2 different things. If it goes through it and it's real straight, that means the 0 happened once. If it bounces, the 0 happened twice, or maybe even more, like an even number of times. This could be an odd number of times. How would you know for sure? In higher level classes, you'd know for sure by that this looks pretty straight, right? If it was like snaky shaped, how many times do you think that 0 would have happened? Like 3 times, like a snake function. Does that kind of make sense? If this was like really, really steep here, like 4th degree, then maybe it happened more than that, yeah. But we're going to say, since it bounced, we're going to do 0 again. So let's write that down in our notes. Make sure you have that. So if you see bouncing, like Gary said, bouncing implies a 0 happens an even number of times. Let's just say more than once. So like twice. So that's good information because now we'll have 3 real zeros, and where do you think the other 2 are? They're imaginary, but we need this answer down here before we can get them. It is, but since it bounced, that implies that that 0 happens twice. Watch. If you don't believe me, watch. I mean, we could pick any guess and just try synthetic division on this, couldn't we? We could try anything in the world. The remainder comes out to 0. It's a 0. So let's see if 0 comes out again. Where? The what?
Did you have to do it on the original problem?
No, because each time, did I do this on the original problem? Each time we're taking the quotient and just knocking it down a little bit further until we can finally get the entire factorization. So that's the idea. Okay, good questions. So let's see. What we're really looking for is this, so I'm going to put it in red. 2, 0, let's see, 4, 0, 8, 0. There we go. So it definitely came out as it worked again. So what's left? This is what we're really searching for. 2 x squared, 4x, and 8. So the question is, can we get the last 2 zeros from that? So I don't think we need our picture anymore. We know the factors are x minus 2. These are both just x, so we could write like x squared, right? This will come together in a second because I'm gonna do it just a little bit different way and you'll see it another way. Okay? And then we know we've got 2 more, so let's just put this. 2x squared plus 4x plus 8. And then we're going to use the quadratic formula on those to get our i's, just like we did yesterday. Okay? And then we'll have all 5 zeros all done with. What would have been another way to get this a little bit? Can you guys see, do these share anything?
2x squared.
They share a 2x squared. So instead of using the graph right away, couldn't we just have pulled out 2x squared? And we could have said, hey, 2x squared, what's left? X cubed minus 8. Minus 8, isn't it? Do you see 2x cubed up, 2x squared in here? Look carefully. X squared, where's the 2? What could you pull out of all those? 2. There's the 2. But where's the x cubed minus 8? Can't we handle that another way too?
Yeah, because the x goes, you just multiply those 2 together and you get the x.
That's the difference of cubes, right? So we could have said x minus 2. Isn't that the way this goes? That's 2 cubed. And then help me with this part. X squared, and over here we put 2 squared, and then in the middle we put 2x, and the sign goes minus plus plus. Is this the same thing as this? Look at it. If you factor 2 out of those and pull it all the way in front, x minus 2, and if you factor the 2 out, that's x squared plus 2x plus 4. Ah! Same thing, right? So 2 completely different ways to do it. Either one is just as good, I think. So it's up to you what you do. But we're still not finished, right? That's completely factored, so that part's done. Done. We need our zeros. We've got some of them. So let's say, yeah, let's write 0 twice. 0, 0, 2. Then we need the other ones, right? So x equals, help me. Let's just write the formula. Negative b plus or minus. Sweet. And now we go, we're looking here, right? You could have done it on here too and you didn't factor out the 2. Either way, it would come out the same. So let's see. Negative 2. Inside we're going to have 4. 1, 4. This looks like yesterday's problem. Crazy. Oh, that was the same problem as yesterday, wasn't it? I think so. Oh, but this was negative. So anyway, we get negative 1 plus or minus square root negative 12 over 2. That gives you your I. If you guys write it like this, you're going to be great. So how about root 12I over 2? 2, 3, 4, 5.
It's also simplified around 4.
Yeah, this simplifies, right?
4, 2 root 3.
So this is really -1 plus or minus root 3I. Yeah, but if you leave it like that, I'm great with that. Okay?
So if we take then our zeros are 0, 0, 2, and plus, minus, and plus.
There you go. There's the elegant answer. Okay? Question, Chris?
Okay, so I understand how you got the 2x squared plus 4x plus a, but how did you get the x minus 2 and the x squared?
Where?
On the top.
Up here?
Yeah.
So you're okay with this, or no?
I'm okay with the part to the right.
That came from synthetic division after we did it 3 times. When we did it 3 times, the first 0 was this part. That's what we tried first from the graph, right? So there's the factor for that 0. And the second 2 zeros where it bounced was just 0. So there's the factors for those 2 zeros, x times x. Yeah, if you have, I mean, you guys would probably have a couple problems like this that are easy, and they might just say, if you have zeros of 7, -3, and 5.7, then the polynomial that corresponds to those is what? X minus 7 and x plus 3 and x minus 5.7, and then you could expand that out and it would be horrible and awful, but eventually you'd get a degree 3 polynomial, blah blah blah, that would have those zeros. So we're just doing that in the other order. Yeah. Okay. You guys have the hour.